Ohm's law is a fundamental principle in the world of electrical circuits, helping us understand how voltage, current, and resistance interact. Think of electricity like water flowing through pipes. In this analogy, voltage is the pressure that pushes the water, current is the flow of the water, and resistance is the friction that slows it down. This simple yet powerful relationship between these three elements is described by Ohm's law, which states that voltage, V, equals current, I, times resistance, R. To dive a little deeper into each component, let's first understand what these terms mean. Voltage, V, is the electrical potential difference between 2 points in a circuit. It's what drives the flow of current, essentially the push that moves electrons through the wires. Voltage is measured in volts, V. Next, there's current, I, which is the flow of electric charge, specifically the movement of electrons through a conductor. It's measured in amperes, A, or simply amps, and is often seen as the rate at which electricity is flowing. Finally, there's resistance, R, which is the opposition to the current flow. Materials with high resistance, like rubber or wood, make it harder for the current to flow, while materials like copper and aluminum have low resistance and allow current to flow easily. Resistance is measured in Ohm's Ohm symbol. Now, the beauty of Ohm's law lies in its simplicity and how it shows the direct relationship between these three elements. According to Ohm's law, current is directly proportional to voltage and inversely proportional to resistance. This means that if you increase the voltage in a circuit, the current will increase as well. Think about it as if you turn up the pressure in a water pipe, more water, or current, flows through. On the other hand, if you increase the resistance in a circuit, the current will decrease, just like how a narrower pipe restricts the flow of water. This principle is crucial in many practical applications. In everyday life, we use Ohm's law to design and build electrical systems efficiently. For instance, when you want to power a light bulb, Ohm's law helps you determine the correct resistor to ensure that the current flowing through the bulb is just right, not too much, not too little. Too much current, and the bulb could burn out. Too little, and it might not light up at all. Ohm's law is also essential when troubleshooting electrical problems. For example, if an appliance isn't working properly, knowing how voltage, current, and resistance are supposed to behave in the circuit allows us to identify where the issue lies. Perhaps the voltage is too low, or maybe there's a break in the circuit creating higher resistance than expected. Whatever the problem, Ohm's law gives us the tools to find a solution. While Ohm's law works well for most materials that maintain a constant level of resistance, called ohmic materials, it doesn't always apply to non-ohmic materials. Some materials, like semiconductors or diodes, behave differently, meaning the relationship between voltage and current isn't a straight line. In these cases, Ohm's law doesn't fully explain how the current will behave. In conclusion, Ohm's law is a critical concept that helps us understand the flow of electricity. It's not just a theoretical idea, it's the basis for designing circuits, troubleshooting electrical problems, and building all kinds of electrical devices we rely on every day. Whether you're powering a light bulb or designing an electric vehicle, Ohm's law is at the heart of it all, making the complex world of electricity a bit easier to understand.